This will be the second lesson for chain rule. It's section 3.7 in our book, and this is the second method for chain rule. So all I want to say, this method is actually the same as rule 1, but it's kind of more like a shortcut. It makes it easier, it makes it faster. So I've highlighted the chain rule here, and what's happening, you have a function on the inside. Just like before, we called that u, and we did a use, we made that u and we rewrote y. But now the problem we had was we can't take the derivative when there's a function on the inside. If this were a single variable, we could take the derivative. The derivative of f of x is f prime of x. But now that we have a function on the inside, I'm going to call that box. So basically you take the derivative of the outside function and you leave the box the same. So g of x is still in there. So you treat the box just like it was a single variable. So the derivative of f of box is f prime of box. But then you have to multiply by the chain, just like if you look back at the chain rule, we had to multiply by the derivative of u with respect to x, the du dx. This is du dx. It's the derivative of the box. So I'm going to walk through why this is the same as the regular chain rule, and then after that we will do some sample problems, and you should find this version a lot easier to do than what we did before. So in the previous section we had the issue, we had to find u, and u turned out to be the function on the inside. So in this case we would have made u g of x, and then we would rewrite the problem and we would have f of u. And so now we have the single variable here, so now we can find the derivative of y with respect to u, and that's just f prime u. And then here we have u and x, so when we take the derivative of that, we take the derivative of u with respect to x, but that's just g prime of x. Now as we do the chain rule, in the original we want dy dx. So what is dy dx? Well, here's dy, so I need dy du. I place that there. But then on the bottom I want dx. That's not dx. Where can I get a dx on the bottom? Well, there's a dx, so I can use du dx, which I have found. And nicely the du's cancel, so this actually works. So dy dx is going to be dy du, which is f prime u, times du dx, which is g prime x. Now if you remember in the last lesson, we don't like u, we want x, so we replace u with the original function. So dy dx by the chain rule is f prime. This gets replaced with g of x times g prime of x. And so if you look, this is the chain rule we have here. And hopefully you can see the connections of how everything worked. So kind of a thought process of what happened. Well, that's an issue. It needs to be just x. So I replaced it with just a variable we called u, and now I can take the derivative normal, just a normal derivative. So if you look at this, this is a normal derivative. But we had u, but u was g of x, and eventually we replaced u back with g of x. So in essence, you take the derivative of the original, treating box as your x. So it's just f prime box, f prime of your box. But then we always multiply, and here's our box right here. We took the derivative of a box, and the derivative of box was placed at the end. So we multiply by the derivative of box. So in summary, if you have f of box, the derivative is f prime of box. Now a big common mistake, people will put the derivative there. The derivative doesn't go there. The original function goes there. The derivative goes there. And I put a little slash there to remind me it's a derivative of the box. So how I look at it, it's f prime of box times the derivative of box. Now this symbol there has no real meaning in calculus. That's what I come up with to help us remember the chain rule. So let's go ahead and look. We have the same issues we had before. We have to recognize what box is. So I will show you the process of how you might do that, and you might practice this. So looking at number 1, we have two functions. I'll call it f of x and g of x. One of them clearly is at 5x plus 4. And then the other one, if you look at it, it's something cubed. So we call that other function x cubed. So either this is f of g of x, or this is g of f of x. Which one is it? Well, if we're looking at f of g of x, g is being placed into the f function. So we're going to put this in for x, and that will get us 5x cubed plus 4. Now f of g of x, f is being placed into g. This is being placed in for the x there. If we do that, we get 5x plus 4 cubed. Now if you look, this is that. So f of x is the box. That is the inside function. So I am going to put a box around there. So how do we do this problem? We have to look at this as box cubed. So as you look at that, I'm going to cover the box. I'm going to make that smaller. So box cubed. You have to think of that as just x cubed. That's how you should view this. So what's the derivative of y with respect to x? Well, it's going to be 3, and then we see the box there squared. We're using the power rule. So you move the 3 in front and decrease that by 1. And then we times that by the derivative of box. Remember? The derivative of box goes at the end. So what does that all mean? Now let's replace everything with what it is. What is box? Well, box is 5x plus 4. And then this is the derivative of box. That would just be 5 plus 0. Let me put the squared there. So this is 3, 5x plus 4 squared times 5. So it's just 15, 5x plus 4 squared. So that is example number 1 using the second chain rule. Now this next one we're going to do, you have to recognize that this can be rewritten as sine x raised to the third power. So you can go through the process we did on the last one where you define f of x and g of x and find out which one's in what. I'm just going to say, just like the previous one, this is box cubed. I have box cubed. So what's the derivative? What's dy dx of box cubed? Well, if you look, you treat box as just a single variable, so you bring the 3 in front, decrease that by 1, so that will get me 3 box squared. And let me put a box here to remind us it's box, not the derivative of box there. Again, a lot of people put the derivative here. No. The derivative of box goes as the chain. Now let's plug in those values. So this box is sine x, and the derivative box is cos x. So let me simplify this. This is 3 sine squared x cos x. And there's my derivative using chain rule. number 2. Let's keep going. This one's similar but different. This one, you need to recognize this is sine of x cubed. It's not sine cubed, it's sine of the x cubed. You can go through the process again, but we're going to realize here is my box. So let me make a box for us. So as you take the derivative, dy dx, you have to look at this as sine of just a single variable, sine of x, but in this case it's box. What's the derivative of sine box? Well, that's cosine of box, but I have to multiply by the derivative of box. So let's do that. What is box? Well, my box is x cubed, and the derivative of box is 3x squared. So we usually put these in front, and then the cosine of x cubed. Alright, that's the derivative of sine of x cubed using the chain rule number 2. And all these problems we just did, the first 3, you actually did that last time we watched the video. Now this one's a little bit different. This one here, let me make my, it's not going to let me, okay, that ain't working. So let me make a box for this one. So if we look at this one, the inside function is that. It's box q to the 3 halves actually. So what's the derivative with respect to x of this? Well, we bring the exponent in front using the power rule, and then we have box, but then we decrease the exponent by 1. That's going to be 1/2. And then you have to multiply by the derivative of box. So again, here you place box, not the derivative. The derivative of box goes on the outside here, which is 10x plus 1. So our answer is 3 square root of 5x squared plus x times 10x plus 1 all over 2. And that is the derivative of number 4. How many more do we have? We have a couple more to do. All right, this one, I actually need some room. So I'm going to hide this problem here. I'm going to color it in white. Is that white? It doesn't look white. You know what? That's not white. It's on the first page. I'm going to hide this for now. Magic. The magic of digital. Alright, so looking at this, what is box? And it might be clear, hopefully, it's clear, that box is that. So what we have is dy dx is, and the derivative of sine of box would be cosine of box, but then we need here the derivative of box. So let's do this. So what is box? That would be e cos x. Now we have a problem. What's the derivative of that thing? That is a composition again. So I'm going to do side work. So off to the side, I highly recommend you do side work. It'll keep you out of trouble. Some of you are going to get into trouble. I'm going to call that inside function z because I already have y used up. Since it's side work, I could call it y, but I want you to get used to changing variables. Variables don't matter. They're just a dummy variable. You can call it anything you want. It doesn't matter. It doesn't change anything. So, oh, I didn't write that right. Our box is e to the cos x. So as side work, I need to find dz dx. I want dz dx, but I have a problem. I have box again. It's e to the cos x. Now let me see if I can, if I make a new box, will it cover that? I don't know why sometimes it's clear and sometimes it's not. Come on, cover it, cover it. It does. I don't understand why. Oh, maybe it's the order in which they were produced. So what's the derivative of e to the box? I need to use the chain rule again. So dz dx is going to be e to the box, I am my own grandpa, times the derivative of box. Well, what is box? Let's take a look. So it remains e to the cosine of x, but the derivative of box, which is cos x, is minus sine x. So now when I take this derivative, it'll be minus sine x e cos x. So that's the derivative of that, which is box here. And I want the derivative of the box there, so this is the derivative of box, and I'm going to place that in there. All that ugliness. Minus sine x e to the cos x. So let me rewrite this. I'm going to put the minus sine x first. Then we have cos e to the cos x times e to the cos x. Again, some of you might be tempted to multiply these. You cannot. This is inside of the cosine function. It's in its home. It can't come out and play. Leave it alone. You're outside all by yourself. That is my final answer. That was 3 functions. It's a function and a function and a function. It is a double chain rule. So I'm going to give you some of those. Those are a little trickier, but I'll kind of break this down. We had sine of box. Well, how do you do that? Well, again, you're treating this box as just your variable. The derivative sine of a variable is the cosine of the variable, or I call box. But the chain rule says we need the derivative of the box. So it's cosine of, again, this box is copied. It's not the derivative. The derivative is over here. Well, I need the derivative of that, but that's not a simple derivative. So off to the side, to find that derivative, I do the chain rule again. So I do this as a single chain rule to find the derivative of box, but once I find the derivative of box, I just plug it in back to where the derivative of box was supposed to be. So that is my second example of first example of composition of 3 functions. So you will have some of those. Now what's next? We are going to be combining multiple rules. So chain rule is the latest thing you learned, but let's go ahead and do this, and we're going to realize we can't just use only the chain rule. So let's go through this process. Now the first thing you should probably do is rewrite this, because square roots are so much easier to deal with when you use 1/2 power. But now here's the problem. You have to recognize we have a product. 2 things are being multiplied. So to find the derivative of product, you have to use the product rule. We're going to leave the first alone. We need the derivative of the second. I'm going to leave space there. Plus, then we take the derivative of the first, I am my own grandpa, and then we leave the second one alone. So here's a problem. We left the first alone. We need the derivative of the second. Side work again. This is side work. I'm going to call it W this time just to be different. W is cosine of x to the 1/2 power. And so I need dw dx, but how do we get that? I don't think I needed that below. So we are going to use chain rule number 2. So you got to recognize it's box to the 1/2 power. So we bring the 1/2 in front, then we decrease the exponent by 1/2, and we place box here, and then we multiply by the derivative of box. Let me draw a line here so I can separate all this out. Well, what is box? Well, that's cosine x. Remember, this is cosine. You do not put the derivative there. The derivative goes here, and the derivative of cosine is minus sine x. So let me rewrite this. You have minus sine x on top. The 2 is in the bottom, and the negative moves the cosine x to the bottom. So you get cos x to the 1/2. And now to rewrite this nice and pretty, you have 2 square root cos x. This is the derivative of the second term. That's what's missing here. So that goes here. I will slide that in. And now I have this beautiful answer. I'm thinking of blowing your minds. I'm considering blowing your minds. I'm going to factor that. I'm going to get it in factored form. Some of you aren't going to like this, but this is a skill that you need to have because sometimes you just have to rewrite things in different ways. So I'm going to look at what both of these have in common. And here's what's crazy. I'm going to rewrite this. I'm actually going to pop this thing back up here before I start. And I'll show you why I'm going to do that. I'm looking for common factors, and you will notice they both have an e to the x. And you should also notice they both have a cos x. So those are the things I want to factor out in front. So I'm going to take out an e to the x and a cos x. Now if you remember, you're supposed to take out the lowest power. So of these two, you always take out the lowest power. For example, if you had an x squared and an x cubed, you would take x squared out, right? If you had an x to the 5th and x to the 1st, you could only take one x out. You always take the smallest power, so I'm going to take out the negative 1/2 because that's smaller than 1. Now, what's left over? Well, I took the e to the x out, and I took that out. I'm left with sine x and a 2, but you know what? I'm crazy. I'm going to take that 2 out also. It's going to be so much prettier. So now I've taken this out, that out, and the 2 out. I left with just sine x. You like the way I talk? I left with sine x. Now, for the second one, this is weird. I took the e to the x out, and what's left with that? We'll explain that. And what happened to the 2? Well, imaginarily, I had a 2 over 2 because 2 over 2 is 1. If I take the bottom one out, I'm left with the top one. So I still have that top 2. This e to the x was taken out here. It's gone. But I'm still left with them cos x's. But what's my exponent there? Here is the rule. When I multiply these together, I better get that. Well, we can double check this. This times this better get me that. Does it? Yes, indeed, Bob, except I forgot the minus. Good thing I checked. So this times this is exactly that. Now this times this needs to be exactly that. Well, the 2 over 2 is taken care of. The e to the x is taken care of. So this times this must equal that. What exponent goes there? Now think about this. If you add two exponents with the same base, you add the exponents. So this one plus this one must equal that one. So I'm going to do this. Negative 1/2 plus question mark, this is question mark, has to equal 1/2. Well, question mark, hopefully you figure out it's 1. So what goes for this question mark here? It's actually 1. And I'm going to replace that with a 1. Some of your minds are really blown. This is not hard as far as mathematical concepts, but it's hard out of tediousness and meticulousness. It's easy to make a mistake. Let's double check. So what's negative 1/2 plus 1? That's positive 1/2 because I add exponents when I'm multiplying exponents. And then I have the 2 there, and I have that 2. Well, that's there. There's my e to the x. I got it all. This is the factored form. Wow, crazy, huh? But now I can do more. Negative exponent, I move it to the bottom. So the 2 stays on the bottom. The square root of cos x is now on the bottom. And now I'm going to put 2 cos x minus sine x because I'd rather have the positive one in front and the negative one after. Believe it or not, wow, that's crazy. That is the derivative of our original using product rule and chain rule. We got one more to go. Isn't this fun? All right, hopefully you see we have box raised to the 5th. That is chain rule. So let me make a box and cover box. So what we have here, let's look at our variables, w and t. We want dw dt. Well, I bring the 5 in front, just like power rule. I decrease the power by 1, so that's 4. So I have 5 box to the 4th, and on the outside I need the derivative of box. But let me make that bigger because I think derivative of box is going to be much bigger than that, and you'll see why. Well, I can do this. 5, what's box? Let's see what it was. I forgot. It's going to be 5t squared over 2t minus 1 to the 4th. Now I need the derivative of that box. Golly gee, how do I take the derivative of that? That requires side work. I'm going to say, hey, my y is going to be the inside or the box part. And this is a quotient. So the derivative of this is low d high. I need more room. Let me move this all somewhere else. Yeah. Let me move it lower. So low d high minus high d low all over low squared. Let me distribute on the top. That's going to be 20t squared. That's going to be minus 10t minus 10t squared all over 2t minus 1 squared. And on top, 20t minus 10t is 10t squared minus 10t over 2t minus 1 squared. I'm going to factor out the 10s and the t minus 1, 2t minus 1 squared. There she blows. That's the derivative of box. So I'm going to take that and I'm going to just slide it right in to where it's supposed to go, right there. Isn't that pretty? Derivative of box. Oops. Oopsie, oopsie, oopsie. I need to, I'm going to undo that. Back up, back up, back up. I put it in the wrong spot. Okay. I want to put it right there. There she blows. All right. Now we can do fun. So that's the heart and soul. So all the rules we've had in here, you're going to use them, mix them up. You need to be proficient in them. I'm going to do some simplification. Watch this. Watch this. I have a 5. Now 5 to the 4th, that's 625. T squared to the 4th is t to the 8th. And on the bottom I have 2t minus 1 to the 4th. Then I have 10t, t minus 1, all over 2t minus 1 to the 2nd. Watch this. Pretty. All on the bottom, I have 6 of those being multiplied. Now let's look at the top. Ooh, I need help. I'm going to ask my girlfriend a question here. 625 times 5 times 10.
It's 31,250.
My girlfriend's so smart. And then we have t to the 9th, because I have t to the 8th times a t, that's t to the 9th, times t minus 1. That is beautiful. I am done. There is the derivative of that strange looking thing. Wow. So beautiful. I think I want to cry. All right, so that is the end of this lesson. Bye-bye.